Hello, and welcome. Welcome to this quiet space, this place of reflection. You have found your way here at the end of the day to this small moment of peace, and that is all that is required of you now. There is nothing to do, nothing to solve. There is only the simple, gentle act of being. Find the position that feels most comfortable. Feel the weight of your body, the way the blankets rest upon you, the softness of the pillow beneath your head. Let us begin by simply breathing. Take a slow, deep breath in, filling your lungs with the quiet of the night, and then a long, slow, easy breath out, just letting the day, all of it, dissolve and fade away. Another breath in, calm and steady, and a long breath out, releasing. You are here. You are safe. And as you rest, as you begin to drift, let your mind float with me. We are going on a journey tonight, but it is a journey of stillness, a journey of thought. We are going to ponder our place in it all. For tonight we begin at the beginning. We begin at home. This world, this earth, it is our cradle. It is the only home we have ever known. Think of it for a moment. This gentle blue world spinning silently in the vast dark expanse. It is a place of impossible, breathtaking beauty. It is the smell of rain on dry ground. It is the feeling of warm sun on your skin. It is the sound of the ocean, a rhythm as old as life itself. It is gravity, that gentle, persistent pull that holds us to the surface. It anchors us. It gives us weight. It gives us a sense of up and of down. We were born of this world. Our bodies are made from its dust, from its water, from its ancient recycled starlight. Every atom in your body was forged in the heart of a star that died billions of years ago. And all those atoms found their way here to this one small, perfect corner of the cosmos to become you. We are all of us an expression of this planet. We are the Earth grown aware. We are the universe thinking about itself. And for a long, long time, this was all we knew. This world was the entire universe. The sky was just a canopy, a roof painted with lights. But then we looked up, we looked closer, and we realized the lights were other worlds. The lights were other suns. And we realized that our home, this beautiful, safe cradle, was not a permanent fixture. It is a difficult thought, and we will hold it gently. It is not a thought for panic. It is a thought for contemplation. It is a thought for a quiet night. Nothing lasts forever. Even here in our cradle, we can feel the changes. We feel the great slow movements of a planet that is alive. The air grows warmer. The ice, ancient and silent, begins to melt. The great winding rivers of the ocean shift their courses. We hear the quiet of species that are no longer with us. We feel the pressure of so many of us all living and breathing and dreaming on this one finite world. These are the great challenges of a species just learning to walk. The growing pains of a civilization waking up, looking at its own hands and realizing the power they hold. These are the tests, the filters. Every thinking species on every world must surely face this moment. The moment they realize they have the power to change their own home and must find the wisdom to protect it. But even if we were perfect guardians, even if we solved every puzzle and healed every wound we have created, there is another clock. A much, much larger clock, a cosmic clock. It hangs in our sky every day. It is the source of all our light, all our warmth, our sun. Our sun is a star, a magnificent burning furnace of golden light. It has been there for us, faithful and steady, for over 4 billion years. It has warmed the first single-celled life. It watched the dinosaurs roam. It has fueled every civilization, every kingdom, every poem, every blade of grass. But the sun, like all stars, has a life cycle. It is not eternal. Right now it is in its beautiful, stable youth. It is burning hydrogen, fusing it into helium in a constant controlled explosion that lights up our solar system. But in the deep, slow-moving time of the cosmos, that fuel will begin to run out. It will not be for a long time, not for 5 billion years. It is a span of time so vast our minds cannot truly hold it. It is 1,000 times longer than all of human history. It is a future so distant it feels like a dream. But the clock is ticking. In that distant, distant future, our star will begin to change. As its hydrogen fuel wanes, it will begin to burn helium, and it will swell. It will expand, growing larger and larger and redder. It will become a red giant. It will grow so large it will swallow the inner planets. Mercury, then Venus, and perhaps even our own Earth. The oceans that we love, the oceans that cradle life, they will boil away. The continents will be scorched and then melted. Our blue world will become a cinder consumed by the very star that gave it life. This is not a tragedy. It is simply a fact. It is the life cycle of the universe. It is the way of things. The stars give life, and in their dying they take it back, recycling those elements for new stars, new worlds, new chances at life. And this knowledge, this deep cosmic knowledge, it gives us a new perspective. It tells us that the cradle, our beautiful blue Earth, is not our final destination. It is our starting place. Life has always been about movement. Life began in the water and it crawled onto the land. It grew wings and took to the air. And now perhaps it is learning to look up at the sea of night and it is dreaming of a new shore. This thought, this grand long-term awareness is what begins the journey. It is the whisper that says go. It is the impulse that turns our eyes to the stars, not in fear, not in panic, but in wonder, in curiosity, as the next natural step. We are the children of the earth, and like all the children, there will come a time to leave the cradle, a time to see what else is out there. But that's a story for another time. For now, there is only this moment, this quiet, this peace. The grand cosmic journeys can wait. The problems of tomorrow and the problems of 5 billion years from now, they can all fade away. All that matters now is your rest. All that matters is this breath and the next. Feel your body growing heavy, so heavy and so very relaxed. Feel your mind letting go, drifting, floating on a calm, dark sea. So how did we read it? How did we move from a faint, fleeting suspicion to a profound discovery? This is the story of how we deciphered the message. It did not happen with a single telescope or a single breakthrough. It was a symphony, a slow, patient chorus of observation. Imagine, if you will, the great eyes of humanity, all turning toward this one insignificant point of light in the darkness. It began on the ground, on the highest, driest mountaintops on Earth in places like Chile and Hawaii. Massive structures of metal and glass stirred in the night. These are our ground-based observatories, the foundations of the chorus. They stared for hours, their giant mirrors gathering every possible photon of light. At first, all they saw was the dot. They confirmed its path, its speed, its orbit. They gave it a name, a designation. But some astronomers noted something odd. The dot seemed just a little bit fuzzy, not as sharp as a distant asteroid should be. It was a hint, the first quiet note in the melody. But from the ground, our view is always blurred by our own atmosphere. We see the universe through a moving curtain of air. To see clearly, we had to rise above it. So the chorus expanded, rising into the silence of space. The Hubble Space Telescope, our faithful aging guardian, turned its precise gaze. For decades, Hubble has shown us the universe in stunning clarity. And as it stared at the object, it confirmed the suspicion. This was no simple dead rock. It was surrounded by a faint glowing cloud. A coma. This meant something was escaping it. Gas or dust or both. The mystery was deepening. We knew something was happening, but we didn't know what. More voices joined. Telescopes designed to see in different kinds of light, some that see in the infrared, the light of heat itself, others that see in the ultraviolet. Each one added a new layer, a new harmony. Data poured in from orbits around Earth. Data was even gathered by our robotic ambassadors on and around Mars who could offer a different vantage point, another angle on this celestial traveller. The chorus was now in full voice, a global and even interplanetary collaboration. Thousands of minds, dozens of instruments, all focused on a single question: what is this object telling us? To find the answer, we had to do more than just look at the light. We had to listen to it. This is where the true magic begins. We use an instrument called a spectrometer. You can think of it as a celestial prism. It takes the faint white light from a distant object and splits it, breaking it apart into its full rainbow of colours. But when you do this to light from a star or a planet, you don't just see a perfect smooth rainbow. You see dark lines, gaps. It looks almost like a barcode. These gaps are the fingerprints of light. Every element, every molecule in the universe, hydrogen, helium, oxygen, iron, absorbs and blocks very specific colours of light. When light passes through a gas, that gas eats its favourite colours, leaving a dark line where that colour should be. This pattern of lines is a unique, unmistakable signature. It is a chemical fingerprint that nothing else in the universe shares. So the astronomers pointed their spectrometers at this fuzzy, mysterious object. They gathered its faint light and passed it through their instruments. They were looking for the fingerprints of common comet materials, carbon dioxide perhaps, or nitrogen. They ran the data, and the result sent a shockwave through the community. The signature was not carbon dioxide, it was not methane, it was water, not just frozen ice. The fingerprint was for water vapour, steam, a massive ethereal cloud of H2O gushing into space. This was the first part of the message. This object impossibly far from the sun, in the deep freeze of the outer solar system where everything should be locked in solid ice, was actively releasing a plume of water. It was a stunning revelation. But it only led to an even bigger question. How? Why was this happening? Was the object slowly melting all over like an ice cube left in the sun? Was it cracking apart? We had the chemical signature, the what. Now we needed the physical picture, the how. For this we needed the most powerful eye we have ever built, the game changer, the James Webb Space Telescope. JWST is different. It doesn't see light like our eyes do. It sees in infrared. It sees the light of heat. While Hubble sees the what, Webb sees the how. It can see the glow of things that are not hot enough to shine, and it can peer through clouds of dust and gas that would blind other telescopes. When Webb turned its segmented golden eye toward this object, the chorus reached its crescendo. The image that came back was breathtaking. It was not a uniform fuzzy ball. The water vapor was not coming from all over the surface. Webb saw jets. It saw focused, structured, brilliant plumes of water vapor erupting from specific locations on the surface. This was not a gentle passive melting. This was a dynamic pressurized eruption. The data was so precise we could pinpoint the source. It was coming from vents, or comet, as you might say. Specific cracks or openings in the object's icy crust. This changed everything. This wasn't a melting ice cube. This was a tiny icy volcano, a cryovolcano. And then as the team watched over the time, they saw something even more profound. The jets were not constant. They would flare up, shine brightly, and then fade away only to flare up again later in a surprisingly regular rhythm. What could cause this? The answer came when they combined the data from all the other telescopes. The ground-based observatories had measured the object's day. They had figured out how fast it was spinning, and when they laid the spin cycle over the images of the jets from Webb, they matched. Perfectly. The picture became clear, sharp, and awe-inspiring. Imagine this tiny world just a few kilometers across tumbling through space. It spins. As it rotates, a specific vent, a crack in the ice, faces the distant weak sun. Even that faint sunlight is enough. The ice in that specific vent warms up, not melting into liquid, but instantly turning from solid to gas, a process called sublimation. The pressure builds beneath the surface like a kettle coming to a boil. And then, whoosh, a jet of water vapor erupts, bursting into space at high speed, but the object keeps spinning. That vent soon rotates back into shadow away from the sun. The temperature plummets instantly. The vent freezes over, sealing itself. The eruption stops. Silence. Until hours later, as the object continues its slow rotation, that same vent, or perhaps another one, spins back into the sunlight. The process begins again. The ice warms, the pressure builds, the jet erupts. This is what we were seeing. Not a dying, melting body, but a living, breathing one. A world that inhales the cold of space and exhales plumes of water. This is the picture that formed. This is the message deciphered. We are not just looking at water. We are looking at a dynamic, active miniature world operating on its own clock, powered by its own internal mechanics. It is breathing right now in the cold darkness farther from the sun than we ever thought possible for such activity. It is a world that is alive, not with life perhaps, but with energy, with change, with a pulse. And it is telling us that the deep outer solar system, which we thought was a silent frozen graveyard of ancient relics, is nothing of the sort. It is an active, dynamic and wondrous place filled with tiny engines all breathing their secrets into the void. And now for the first time we are able to listen. And so as we continue to watch this Dynant Visitor 3i or Atlas, our perspective begins to change. It is a subtle shift at first happening in the quiet corners of the mind. It is the feeling you get when a familiar word suddenly sounds strange, or when you look at a map and truly realize the scale of the oceans. You realize you are no longer just looking at a comet. That word comet feels too small now, too familiar. A comet belongs to our sun, born from our cloud of dust and ice, orbiting in a predictable, comfortable path. We know them. They are part of our family. This visitor is not part of our family. It is a traveller, a messenger, and most importantly, it is a laboratory delivered to our doorstep from an entirely different star system. This isn't just another rock. This is a profound physical piece of evidence that changes how we map our place in the cosmos. Why is this so important? Because it challenges everything we thought we knew. For decades, our scientific models, our best explanations for how the universe works, were built on what we could see, and all we could see really was our own solar system. We built theories about the space between the stars, that vast, cold and lonely emptiness. We assumed it was a brutal place, an unforgiving desert. Imagine trying to carry a simple cube of ice across a desert that is millions of miles wide. The dry heat would turn it to vapor long before you took 100 steps. The interstellar medium we thought was like that. We believed that any icy object cast out from its home star would be slowly and relentlessly destroyed. Over millions of years, the cold vacuum of space would sublimate its ice, turning it directly into gas. It would be bombarded by cosmic rays, high-energy particles accelerated to nearly the speed of light by distant supernovas. It would be bathed in ultraviolet light from massive hot stars. We were certain that any water, any frozen methane, any carbon monoxide, all the materials we call volatiles should have been scoured away, blasted into nothingness, leaving only a dry, dead husk of rock. 3 Atlas tells us that our models were wrong, or perhaps just wonderfully incomplete, because this visitor is not a dry husk. It is alive with activity. As it neared our sun, it warmed up and it began to breathe. Our telescopes detected water. They detected gases that should have been lost to the void millions of years ago. This single, simple observation forces us to go back to our desks, back to the fundamental questions. How does a fragile object mostly made of ice protect itself? How does it survive a journey that may have lasted hundreds of millions of years, drifting through the dark ocean between the stars? This object is a puzzle. It demands new answers. Perhaps it was shielded, protected by a thick, dark crust of dust and complex carbon molecules like a blanket insulating its precious cargo. Or maybe it was once part of a much larger body, a piece of an alien planetesimal that shattered, and it has not been travelling for as long as we assumed. Whatever the answer, it opens a door. It tells us that the universe is far more capable of preserving the ingredients of worlds than we ever dared to imagine. This is why we also call it a time capsule. Think for a moment about the ice deep in Antarctica here on Earth. Scientists can drill down miles deep and pull up a core of ice. In that ice trapped in tiny ancient bubbles is the air from 100,000 years ago. They can read the history of our own climate, a story written in frozen water. 3 Atlas is an ice core too, but it is not an ice core of a planet. It is an ice core of an entire unknown solar system. It carries within its frozen heart the chemical memory of its birthplace. It is a perfect, pristine fossil. It's a fragment of the original cloud of gas and dust that collapsed to form its own sun and its own set of planets somewhere else in the galaxy. When our telescopes analyze the light shining through the gases that surround it, we are not just seeing chemicals, we are in a very real and tangible way tasting the ingredients of another world. It is the geology of a place we will never see. It is the raw material that was available when that system was born. Does that system have more carbon than ours? Does it have less nitrogen? Does it have strange, complex, organic molecules that we have never seen before? Molecules that could be precursors to biology. This isn't just a different recipe, it's a different kitchen. Every particle of dust, every molecule of water is a letter in a sentence written in a chemical language we are just beginning to understand. We are reading a postcard sent by an unknown neighbour, a neighbour we didn't even know we had. And this is where the map of our thought truly begins to tear, where the boundaries dissolve. This is the idea that should echo in your mind as you drift deeper into rest. The discovery of 3 Atlas and the other interstellar visitors that will surely follow fundamentally changes our understanding of the galaxy itself. We used to think of star systems as isolated islands. Each star we thought had its own private collection of planets, its own supply of water and rock, and they all stayed put, separated by an impassable ocean of empty space. These objects prove that is not true. They are the ferries, they are the messengers. They demonstrate with their simple physical presence that solar systems are not closed. They are leaky. They are constantly throwing material out, ejecting comets and asteroids into the common space of the Milky Way. Now consider what this material is. It's not just dead rock. We found water ice. We have found carbon-based molecules, the complex organic stuff of life itself. These are the building blocks, the very same elements that make up your body, the air you breathe, and the world around you. 3i Atlas confirms that these materials are not unique to us. They are being manufactured in countless other star systems, and crucially it confirms that these materials can travel. They can be packaged, protected, and shipped across the galaxy. What does this imply? It suggests that the galaxy is constantly cross-pollinating itself. It hints that the origin of life on our own Earth may not have been an isolated event. Perhaps the water in our oceans was not here from the beginning. Perhaps the first complex molecules that sparked biology, that first flicker of consciousness, did not begin here at all. Perhaps they were delivered. Billions of years ago, a visitor just like 3i Atlas, a messenger from another star, may have splashed into the young oceans of Earth, seeding our world with the necessary ingredients. This idea has a name, panspermia. For a long time it was considered science fiction. But these visitors, they are the delivery mechanism. They are the physical proof that it is possible. This means that the potential for life is not a rare localized miracle that happened only on our small blue world. It suggests that the ingredients are everywhere. The galaxy, it seems, might be filled with water, filled with organics, all drifting on these sun-icy messengers passing from one star system to the next, just waiting for a welcoming shore, waiting for a young planet orbiting at just the right warm distance from its star. 3i Atlas didn't just fly through our solar system, it flew straight through our most profound and perhaps our most lonely assumptions about our place in the universe. Our visitor is now moving away from us, a faint speck of light returning to the darkness from which it came. But for us here on Earth, the most exciting part of the journey has only just begun. The encounter may be over, but the investigation and the hunt for understanding is in full swing. Think of it like this. A guest from a far-off unknown land has just walked through your house. They didn't stay long, perhaps only for a few minutes. They didn't speak your language. But as they walked through, they left footprints. They left behind a few threads from their clothing, a faint scent in the air, a fingerprint on a glass. The guest is gone, but the clues are everywhere. This is what is happening right now in observatories and universities all across our planet. The comet 3i Atlas has left us a trail of precious, priceless data. The real work is not in chasing it, but in sifting through the marvelous clues it so generously left behind. All those hours our telescopes stared, all the light they gathered, all the chemical signatures they recorded. This is the treasure. This is the material that scientists will be studying for years, perhaps even decades. The comet itself is already disappearing, becoming a memory, but the information it gave us is permanent. It is a gift from another star system. So what are scientists looking for now? As they lean over their computers analysing spectrums of light, what is the fingerprint they are searching for? They are hunting for its chemical birth certificate. Every object in the universe is made of atom, but atoms sometimes come in slightly different versions called isotopes. Think of them as the same brand of car, but one model has a slightly heavier engine than the other. They are both the same car, but a mechanic can tell the difference. The element we care most about here is hydrogen, the building block of water. Most hydrogen is just a single proton, but a very small amount of hydrogen in the universe also has a neutron, which makes it slightly heavier. We call this heavy hydrogen, or deuterium. When deuterium pairs up with oxygen, it creates heavy water. Here is the beautiful, simple secret: the amount of heavy water compared to regular water in a solar system is not the same everywhere. This ratio, this simple percentage, is a direct result of where and when the water was formed. A system that formed in an extremely cold, distant cloud of gas will have a different water ratio than a system that formed in a warmer, more turbulent region. Our own solar system has its own distinct fingerprint. We have measured the water on Earth, on Mars, and in the comets that were born with our sun. We know our own family's chemical signature. Now we have a sample from another family. By measuring the heavy water in 3i Atlas, scientists can read its birth certificate. They can begin to answer the most fundamental question: where did you come from? Does its water accent sound like ours? If it does, it might suggest that the building blocks for life, for water and planets, are common across the galaxy. It would mean that our solar system is not so unique, but perhaps one of many, many siblings formed in a similar way. But what if the ratio is completely different? What if it's wildly, strangely unlike anything we have ever seen? That too would be a stunning revelation. It would tell us that this visitor comes from a place that formed under conditions we have not yet imagined. A system with a different history, a different chemistry, a different story. This single measurement, this simple ratio, is the key to unlocking its past. It is the first line in a biography written billions of years ago in a place we may never see. The hunt for this number is one of the most important goals of the entire observation campaign. The comet is gone, but its story is just waiting to be read in the light it left behind. As with any great mystery, the arrival of 3i Atlas brought with it a wave of excitement, but also a wave of confusion. Our minds try to grasp this new thing by comparing it to things we already know or things we imagine. It's only natural. But part of this journey of understanding is to gently clear away the fog of misconception to see the visitor for what it truly is. There are two major points of confusion that are important to clarify. Not to dismiss the wonder, but to focus it on the real mystery. The first point of confusion is the comparison to another famous interstellar visitor, Oumuamua. When Oumuamua tumbled through our solar system in 2017, it was a profound shock. It was the first we had ever seen, but Oumuamua was a deep, unsettling puzzle for a very different reason. It was silent. It was dark reddish and shaped perhaps like a cigar or a flat pancake. As it passed the sun, we expected it to act like a comet. We expected it to turn on to release a cloud of gas and dust a beautiful tail, but it did not. It remained quiet. It held its secrets close. It gave us almost no clues. It was like a piece of cosmic driftwood, ancient and inert, just passing through. It was a mystery of silence. Now compare that to 3i Atlas. This new visitor is the complete and total opposite. It is not scant, it is singing, it is scuttering its presence to us. From the moment we saw it, 3 Atlas was active. It wasn't a dead piece of rock, it was a living, breathing, in a geological sense object. It was surrounded by a massive glowing cloud of its own atmosphere, its coma. It has a spectacular tail, a shimmering banner of dust and gas stretching across millions of miles. Oumuamua was a locked box, 3 Atlas is an open book. It is actively ejecting massive amounts of the water ice. It is rich in carbon. It is telling us in clear chemical language, I am a comet, I am made of water, I am made of the building blocks of life. Where Oumuamua was a quiet, mysterious rock, 3i Atlas is a vibrant, active and astonishingly wet world. This makes it in many ways an even more profound discovery. It is not an anomaly. It is proof that other star systems grow comets just like ours. It shows us that the same ingredients that formed our oceans are wandering the galaxy. This visitor is not a puzzle of silence. It is a puzzle of activity. This brings us to the second and perhaps more common point of confusion. When people hear that the comet is water-rich and ejecting jets, the imagination immediately leaps to a fantastic image, a rogue planet with a vast liquid water ocean sloshing around under a thin crust of ice. It is a beautiful thought, but the reality of space is far colder and in many ways far more complex. What we are seeing is almost certainly not a liquid ocean in the way we think of one on Earth. To maintain liquid water, you need a delicate balance of temperature and pressure, and this comet is a relatively small body frozen solid by its long journey through interstellar space. So if it's not a liquid ocean, what are we seeing? What is the source of these enormous plumes of water vapor? The truth is likely found in reservoirs. Imagine the comet as it was forming billions of years ago in its home system. As it grew, it trapped not just water ice, but other gases like carbon dioxide and carbon monoxide, which were frozen solid. It trapped them in pockets deep inside its body. For billions of years, these pockets have been locked away in the deep freeze of interstellar space under incredible pressure, perfectly preserved. They are time capsules. Then, after its long journey, the comet approaches our sun. For the first time in perhaps a billion years, its surface begins to warm up. Heat is a powerful engine. This new warmth from our sun doesn't just melt the surface and it penetrates. The heat works its way down through cracks and fissures deep into the comet's heart. Eventually, that heat reaches one of those ancient pressurized reservoirs. What happens when you heat a can of pressurized gas? It explodes. This is what we are likely seeing. The ice doesn't gently melt into a pool, it goes straight from a solid to a gas in a violent process called sublimation. The trapped gases expand, building up pressure, until they find a weak spot in the crust, a vent, a fissure, a crack. And then, with incredible force, this pressurized gas bursts out into the vacuum of space, carrying with it tons of dust and water ice. This is the jet. This is the plume. So we are not looking at a single simple ocean. We are looking at a complex internal plumbing system, a vast network of hidden chambers, ancient reservoirs and geological vents that have suddenly been brought to life by the warmth of our star. This in itself is a staggering thought. This object is a geological engine. It is a machine built by nature that has been dormant for eons, and we just happen to be watching at the exact moment it turned on. This leads us finally to the true mystery. This is the question that is keeping astronomers awake at night. It is the puzzle that will be debated for years to come. When we see something so strange, so powerful, it is human nature to jump to the most dramatic conclusion. And in our culture, the most dramatic conclusion is often, it must be aliens. Is it a spaceship? Is it an artificial structure venting its engines? It is a fun thought. But the universe has proven time and time again that it does not need our imagination to be strange. Nature itself is more creative, more bizarre, and more powerful than anything we can invent. The real mystery of 3i Atlas is not, is it aliens? The real mystery is, what physical mechanism is driving these jets? We have seen comets from our own solar system. We have seen them sprout jets. But 3i Atlas is doing things we have not seen before. The way it is releasing its gas, the timing of the jets, the sheer amount of material, it is different. It is behaving strangely. Why? Is this what all comets look like when they are new? Is 3i Atlas a virgin comet, one that has never approached a star before? Are we seeing the raw, violent initial reaction of a pristine object to sunlight? Our own comets are old. They have passed the sun many times, they are tamed. Perhaps this is what they all looked like on their very first pass. Or is the mechanism related to its spin? Is the comet spinning in such an unusual way that it heats one side, causing a buildup of pressure that then releases? Is it tumbling end over end, causing its vents to fire off like random bursts? Is the comet's core fractured? Did something happen to it on its long journey? Perhaps it is not one solid object, but 2 or 3 smaller pieces loosely held together, rubbing against each other and creating heat from friction, powering the jets from the inside out, not just from the sun's heat. This is the real work of science. The question is not who, but how. How does a frozen object, after billions of years in the dark, come alive in such a spectacular way? What is the engine? What is the process? These are the questions that remain. They are deeper, more fascinating, and more important than any simple science fiction story. Because in answering them, we learn not about some imagined intelligence, but about the fundamental rules of the cosmos. We learn how worlds are built, how water is transported across the galaxy, and how the ingredients for life are scattered among the stars. The comet is now fading, a silent traveller on its way back to the infinite night. It leaves in its wake a cloud of dust and gas, but more importantly it leaves us with these questions. And as you drift off to sleep, you can let your mind drift with them. You can rest secure in the knowledge that even as we sleep, someone is watching, someone is analysing the data, someone is hunting for the answers. The comet is gone, but the quest for understanding the greatest journey of all has only just begun. And so after a long journey we return. We have travelled from the final dying light of our own sun to the edges of human possibility on distant worlds. We have weighed the silence of the galaxy, the profound and echoing question of the Fermi paradox, and we have considered the great filters that may lie behind us or still terribly ahead. We have looked at our own reflection and seen a new species, a post-humanity evolving in the cold darkness between the stars. After all this, after all these vast and cosmic ideas, it is easy to feel small. It is easy to feel separate. But the final message of the cosmos is not one of separation, it is one of connection. We come back to ourselves, to this planet, to this moment, but we are not the same. We have changed. Our home, this solar system, once felt like the entire universe. Then it felt like a small walled garden, a secure island floating in an endless empty ocean. We built our maps, we named the planets, and we felt a sense of completion. This was our home. Then the visitors came. First there was Oumuamua, a strange name for a strange traveller. It was dark-shaped like nothing we had ever seen, and it was moving too fast. It did not belong to our sun. It was a tourist from another star tumbling through our neighbourhood, a piece of interstellar driftwood washed up on our shore. It did not stop, it did not slow down. It simply waved as it passed, using our sun's gravity to fling itself back into the deep. It was a profound shock. The walls of our garden were gone. Then, not long after, another traveller was spotted, and another. The visitor-designated 3i discovered by the survey known as Atlas reminded us that this was not a rare event. It was a constant flow. Our solar system is not an island. It is a port. It is a harbour on the great galactic ocean. We are part of an immense neighbourhood, a swirling city of stars where matter is constantly endlessly exchanged. Think about what this means. When a star is born, it is messy. It throws off gas and dust and rock. When a star dies, it explodes in a supernova, seeding the galaxy with the heavy elements of life. The iron in your blood, the calcium in your bones. It was all forged in the heart of a star that died billions of years ago. You are quite literally made of stardust. But these visitors, these comets and asteroids from other stars, they tell us something new. They tell us that the systems themselves are connected. The galaxy is a single breathing ecosystem. That strange rock Oumuamua was a piece of another solar system, perhaps one that was born billions of years ago. It travelled for millions of years in the dark and the cold, carrying the chemical signature of its birthplace. It tells us that a piece of our solar system, perhaps a comet flung out by Jupiter in our deep past, may right now be tumbling past another star in another part of the galaxy. We are not just sharing the atomic dust of long-dead stars, we are actively trading pieces of our homes. We are connected not just by a shared past, but by a shared present. There is no over there, it is all in a very real sense here. This is the true echo of the cosmos. It brings us to our final quiet realization. The universe is not a museum. It is not a static catalogue of facts, a finished painting that we are simply trying to admire. It is a story. It is a dynamic, living, breathing narrative that is being written right now in this very second. It is a poem that is unfolding, and it is full of surprises. For centuries we thought we knew the rules. We mapped the stars, we predicted the comets. We thought the universe was a great perfect clock, and our job was just to figure out how the gears worked. But we were wrong. Every time we build a new eye to see or a new ear to listen, the universe surprises us. We pointed a telescope at what we thought was empty space and found thousands of galaxies. We tried to measure the slowing of the universe and discovered to our shock that it is speeding up, pushed apart by a mysterious dark energy we still do not understand. We built detectors to listen for the sound of gravity, and just as we turned them on, we heard the impossible echo of two black holes colliding a billion light-years away. We are not the masters of this story. We are not even the main characters. We are the audience just waking up, arriving in the middle of the play, and we are only just now beginning to learn how to listen. We listen with radio telescopes, tuning into the ancient background hum of creation itself, the cosmic microwave background. This is the echo, the faint warm static of the Big Bang still filling every corner of space, still washing over you right now. We listen with great mirrors that can see the infrared light from the very first stars, ghosts from the dawn of time. We listen for the whispers of gravity, the ripples in spacetime that tell us of cosmic collisions. We listen to the light from distant planets searching for the telltale signs of air, of water, of life. The cosmos is not silent. It is full of messages. They are not in a language we understand with our ears, but in a language of physics, of light, of gravity, and of time. And the story is far from over. It is a story of constant creation, of unexpected turns, and of infinite possibility. We are a part of that story. You are a part of it. The atoms that make up your body were born in this grand cosmic narrative. You are the universe becoming aware of itself. You are the way the cosmos listens. As you rest, as you drift, feel that connection. Feel the gentle ancient hum of the universe. It is not outside of you. It is in every breath you take. The story will continue, the stars will keep burning, the visitors will keep travelling. And we will be here for a short while as the witnesses, as the dreamers, as the echo of the cosmos itself.